the length of PQ. So that's point P, point Q. So 2.1.1 PQ will be equal to the square root of x1 minus x2 squared plus y1 minus y2 squared. Now, I just need to emphasize this. If you start with x2 minus x1, y2 minus x1 is 2 correct. If you use xp based on the endpoint of the line segment, it's also correct. So you can write as xp minus xq, yp minus yq. Any of those, they're all correct. Right? Then we substitute my x1. Let me consider point P as my x1. So I'm going to have 1 minus x2 is going to be a 6 squared plus y1, that's a 0, and y2, that's a 3. Right, so this is very straightforward. And you get minus 5 squared plus minus 3 squared. And that will give you the square root of 25 plus 9, and you get the square root of 34. So if you did the work, remember this was last week's work, which you should have done. Okay, on Friday, I was only able to do the first question. Okay, so the answer will be square root of 34 units. Unfortunately, you can't rationalize square root of 34. It cannot be rationalized. Right? Then 2.1.2, the gradient of PQ. The gradient of PQ. Now, gradient, I'm sure you know by now, you should be marking your way, not copying everything. You should be marking your way because you did the way. So 2.1.2, the gradient of PQ, I can write this as YP minus YQ over XP minus XQ. Okay? Now, here I'm being specific. Instead of using Y2 minus Y1 over X2 minus X1, yes?
So now when we're writing our formula, we give marks to that, right?
Sometimes.
Sometimes. So instead of writing Y1, YP minus Y2, so we could change in Y over K X, and then we can substitute that into that formula.
That's not encouraged. I don't encourage you to write it as this. I don't encourage you to write it like that. Write it like this. Okay. So, right. So, point P, my Y base 0, my Y is Q is a 3. So this will be 0 minus 3 over the X, we have got 1 minus 6. So that will be 1 minus 6. And then you get negative 3 over negative 5. This gives you positive 3 over 5. Okay? So that's your answer there. Okay, now you can also look at the straight line itself. It is slanting to the right. Therefore, the gradient is positive. If a straight line is slanting to the left, its gradient will be negative. Slanting to the right, its gradient will be positive. Right? So you can see that then. Let's move on to the next question. Now, the next question, it says the coordinates of T. Now, if you read the question, it says T is a point on PQ such that T is a midpoint. So this point here, it's a midpoint of PQ. It's a midpoint of line segment PQ. Therefore, I'm going to use the midpoint formula. Since T is a midpoint, I can answer that question as T is my midpoint.
Right, so how do you know T is the midpoint?
Because it's written here. Okay, so that will be x1 plus x2 over 2. If you want, can you stop that? If you want, you can also write it as xp plus xq, right? That would be y1 plus y2 all over 2. Please take note, I'm being specific here because our midpoint is t. Generally, the formula will have an m here. But for this question, I'm allowed to be very specific, right? So this will be T x1, it's a 1, x2, it's a 6, divided by 2, y1, that's a 0, plus y2, that's a 3, right? So this will give you 7 over 2, and that one will give me 3 over 2. So if you did the question, I expect you to be marking your work. Okay? Right? I expect you to be marking your work. Right? Okay, then the next question now says the area of triangle QTR. Now, when you get a question on area, okay, in most cases at this stage, because you haven't done the area rule in grade 11, you have to use the formula of a triangle, which is a right angle triangle. Half base times what? Times height. Now, in most cases, for questions like this, they have to give you a right angle triangle. But later, after we have done the area rule, you may get a triangle which is not right angle. Okay, then we have a special formula for calculating area, which is a new formula. But for this question here, we are told that PQ is perpendicular to RQ, which means triangle PQR is a right angled what? Triangle. Therefore, and also we have got QTR. Now, QTR is going to be a right angle triangle as well, which means we can use half base times perpendicular height to calculate its area. Right? Are you following that? So, if you want to calculate the area, you might need the length. Now, do we know any length there? We don't know. But the good thing is, we covered the length of PQ. Okay? Point T is a midpoint. Therefore, TQ is half of what? Of PQ. So we can get that. Then we need the length of QR. So I'm going to calculate the length of QR. Okay? I'm going to calculate the length of QR. Let me go to the next page. So we are now doing 2.2.1. So the length of QR is going to be xq minus xr squared plus yq minus yr squared. Then I'm going to substitute. Okay? I'm going to substitute. Okay, the substitution is very simple. So my xq is 6 and my yr is 9. So that will be 6 minus 9 squared plus 3 minus minus 2, 3 minus 2 squared. This will give you minus 3 squared plus 5 squared. And then you get the square root. This is 9 plus 25, you get 34. Okay? Okay, so that's QR. Right? Then we need the length of TQ. Now TQ is half of PQ. Now we calculate the length of PQ area. Okay, it was square root of 34 as well. So I'll say TQ is half of PQ, and this will be half times square root of 34, which is the same as square root of 34 over 2. Okay, so now I have a base, I've got my height. Therefore, I can calculate the area of triangle QTR. Right? So the next thing, to write my formula, area of triangle QTR is going to be half times, okay, my base is TQ. Please, here, there's no special rule. It's your choice. You can make TQ your base and QR your height or vice versa. So this will be times QR. And that will be a half times square root of 34 over 2 times the square root of 34, and that will give me 34 over 4, right? And then I'll get 17 over 2, which is 8,5 square units.
So it's
Yes,
how do we know that QR is the perpendicular?
it's given. If you look at the diagram, the 90-degree angle is there. So it's your choice to decide whether you want to make TQ your base or QR your base. Either way, you get the same result. Yes.
If you took the whole time PQR and divided by 2, it's still correct.
It could be because PQ is equivalent to QR. So it will be possible that you can get the same answer. Because point T, it's a midpoint. But now the thing is, we don't know whether TR is a perpendicular bisector. Okay? If it was a perpendicular bisector, then I would suggest that you can go via that. But here it's not clear now. It can come up later, but if it was a perpendicular bisector, then we could use the fact that triangle QTR is half of QPR. You would get the same result. Right? But don't make assumptions if the information is not there. Any question?
Well, it's not equivalent to the other.
Any question? Hmm? Any question? All right. Can I carry on? All right, let's carry on. Right, 2.2.2, the size of theta with reasons. Now, theta is this angle here. Okay? But we are given the size of that exterior angle. So we could use the exterior angle of a triangle theorem. So here, your Euclidean geometry is required. Okay? Now, your analytical geometry, some of the questions have a connection with Euclidean geometry. Okay? The good thing is you've done Euclidean geometry this year already. So some of the concepts from Euclidean, you need them here. So to calculate theta, it's going to be very easy because this angle here is 90 degrees. So 121 is going to be 90 plus theta. So that will be very easy. So 2.2.2, I'll say 121 degrees is equal to theta plus 90 degrees. Then you're using exterior angle of a triangle. Now it is possible that you may not get a mark for the reason, but to go on the safe side, write the reason down. Okay? Or a mark can be allocated for the statement and the reason. So if you don't have the reason, you may end up losing the mark. So this will be theta equal to 121 minus 90 degrees, and that will give you 31 degrees. Okay? Right? Yes?
Can we say that the angle of S is equal to 180 minus 121 angles of straight line?
Yes. You can also you can also go by that way. If you can't see that, you can use the exterior angle of the triangle theorem, then you calculate the interior angle by subtracting 121 from 180, and then you get 59. Then you get 59 plus 90, you subtract the sum from 180, from 180 you get 50. That's also another way. Okay? Because in actual fact, a lot of learners might not see the exterior angle of a triangle theorem. So if you can do it that way, that's fine. Okay.
So,
Yes.
haven't you done this?
When?
Excuses, sir.
No.
I'm pretty sure we
All right.
done this. We have
Okay.
the zeros.
Calculate S. Now S is these are the coordinates now. The coordinates here. Okay. Now I'm sure you are aware that the value of y here is 0. Okay. Now if you want to calculate the value of x here, okay, my suggestion is find the equation of QR. Then you substitute 0 into into it where there is y. Then you solve for what? For x. Right? If you can figure out another way, that's fine. But I suggest that find the equation of QR, then you substitute y equal to 0 into that equation, you get the value of x there.
So for linear graph, the equation is y plus c.
It's y equal to mx plus c. So let's do that now. Right, be aware that the gradient of PQ, we already got it. Right? What was the value of the gradient of PQ? It was 3 over 5. Yeah, we got it here.
Yes.
We got it. Yes. There. So since I'm sure you can see here that we can see that PQ is perpendicular to QR. Therefore, the product of their gradients is equal to minus 1. Which means you don't have to calculate the gradient of PQ, or sorry, of QR directly by using change in y over change in x. You can use the gradient of PQ. This is what I'm going to do. But if you don't realize it, if you're writing a test, then calculate the gradient of QR. Okay? So here I'm going to say MPQ times, let me label application that's 2.2.3, 2.2.3, MPQ times MQR, that's equal to minus 1. This is 3 over 5 times MQR, that's equal to minus 1. Now, by now, you should know that when you are multiplying two gradients and if their product is supposed to be minus 1, it means if one is negative, the other one is what? Positive. And vice versa. If one is a common fraction, the other one, in most cases, it will be an integer or it will be the reciprocal. So if this is 3 over 5 times MQR, it means MQR, if you solve that equation, you get minus 5 over 3. It will be a negative reciprocal of 3 over 5, the answer. Because 3 over 5 times minus 5 over 3 is equal to minus 1.
So why do we do this?
Because I want to find the equation for QR.
So why not? Okay. So you just trying to find the gradient for QR.
You can't find the equation for QR without knowing its gradient.
So then why do you use PK to find QR?
Because the two lines are perpendicular.
But can't we just find QR by itself?
It's the same thing.
Okay,
I mentioned it. Listen, if you are writing a test analytical geometry, I can assure you that some learners will pass the gradient of QR. Some will see that it's not necessary. You can use the gradient of PQ. Either way, you get the same one, same answer. Okay? All right. So we are there now. It's very important for you to know that if two lines are perpendicular, the product of their gradient is minus 1. One of the two lines where the negative gradient, other one where the what? Positive gradient. Always. Okay? For you to get the product, it is negative 1. And the two answers must be negative reciprocals of each other. I'm sure you can see that we have 3 over 5, and this becomes minus 5 over 3. Okay? Because the product is negative 1. Or if you think you can get confused, just solve this equation. It's a grade what? Maybe grade 8 or grade 9 equation. Okay. I'm not supposed to teach you how to solve that equation. Then, to find the equation, it is your choice. I'm going to choose the coordinates of R. You can also use the coordinates of Q. But I'm going to use the coordinates of what? Of R. Then, all right, y equal to mx plus c. My y is negative 2 and my x is 9. Negative 2. My m is minus 5 over 3. My x is a 9 plus c. Right? Hope you are following that. Now, this is grade 9, what I'm doing now. It's grade 9 linear function. So this will be minus 2 equal to minus 45 over 3 plus C. Then from here, I want to solve for C. So you take the minus 45 over 3 to the other side. Then you get C equal to minus 2 plus 45 over 3. And that will give me minus 6 over 3 plus 45 over 3. And that will give me 39 over 3.
Sir,
That's
wait,
13, sir.
it's 13.
Wait. Listen,
Oh,
you are using a calculator. Mr. Chikula is not using a calculator. So I'll get 39 over 3, which is equal to 30.
Oh, yes.
Right? Then the equation will be equal to y equal to, now m is minus 5 over 3, so that will be minus 5 over 3x plus 13. Then, to find the coordinate of x here, the value of y there, it's a 0. So I'll substitute y equal to 0. And then you get minus 30 equal to minus 5 over 3x. To simplify this, you get x equal to 39 over 5. Which is a 20. No, you can't round it off. Okay, so the answer will be 39 over 5. Then you have to write your final answer in coordinate form. So that will be point S, x is 39 over 5, and y is 0. Okay, and then you are done.
So 39 over 5 is 16.
No,
So if we round it off,
don't round it off.
is it wrong?
It will be incorrect if you round it off. Okay, and then the last question says, determine with reasons the gradient of the line through T and the midpoint of PR. Okay, determine with reasons the gradient of the line through T, passes through point T, and the midpoint of PR. So the line passes through the midpoint of PR, and then it goes something like that. What did you do this question?
So it's going to be parallel to PR.
So it's going to be like that, right? So it means this is going to be a midpoint, that's a midpoint, okay? Right? Remember you did the midpoint theorem in grade 10. Don't forget that. Yeah, you are in grade 11, you did midpoint theorem last year. It's part of your Euclidean geometry. Therefore, if this is the case here, right, then we say TT is equal to TQ, right? This is based on the fact that T is the midpoint of PQ, right? Also, P, right? This point, okay, this is analytical, so you're allowed to do a bit of some construction. So if I call it maybe point, which letter do you want me to call this point?
Z.
Okay, let's call it Z. So PZ will be equal to RZ. Now, what this means that Z is a midpoint of what? Of PR. Okay? Now, I'm sure you know this, that once you have got a line that bisects two sides, okay? If it bisects two sides like this here, then we can call it the midpoint what? The midpoint theorem. So the deduction will be therefore TZ will be parallel, or I can write it will be parallel, to QR. And my reason, midpoint theorem. My reason here will be midpoint theorem. Okay? Please, you cannot rush to just say TZ is parallel to QR without mentioning this, without getting those two statements and the reasons. Right? Furthermore, we can end up saying here TZ is equal to half of QR, and the reason is also the midpoint theorem. But we are mainly concerned with gradient. We are mainly concerned with gradient. So the first statement that says TZ is parallel to QR is the most important. Okay? Because if TZ is parallel to QR, therefore means their gradients are what? Are equal. Therefore, the gradient of TZ will be equal to, what was the gradient of QR? Minus 5 over what? 5 over 3. And you can give a reason here and say TZ is parallel to QR because I have proved it there based on the midpoint theorem. If you are answering questions on analytical geometry, your knowledge of Euclidean is required. Okay? You cannot take that away from questions on analytical. All right? So I